Viewers at home, I am Mr. Okote Pius. Welcome to the concluding part of the topic variation. In the first episode, we have been able to look at what is the meaning of variation, and we were able to list the types of variation, and also we were able to carry out calculations on direct variation and inverse variation. Now, welcome to episode 2. Viewers at home, I will urge you, get your writing materials and get yourself off distraction. Now, we are moving straight to joint variation in this episode 2. Now, looking at the example on board, we are asked that if y varies directly as d and inversely as the square of x, if d equals to 30, x 24, and y equals to 1/18, we are asked to find the law connecting the variables. Also, we are asked to find y when d is 5 and x is 2. Now, looking at the word joint variation, the word joining two other types of variation. Now, under joint variation, we are combining our understanding and the knowledge that we have acquired from episode 1, the direct variation and the inverse variation. Now, if you look at the question, we have the word directly and we also have the word inversely. Now, come straight to the solution. Y varies directly as d. Y varies directly as d. And inversely as the square of x. Y is also inversely proportional to x squared. Now, to combine these two statements, that y varies directly as d and inversely as the square of x. This is the square of x and this is our variable d. Now, to combine the two is now going to be y equals to d over s squared. We have been able to successfully join these two variables. They were separate entities, but under joint variation, this is how to combine it. Under joint variation, this is how to combine it. Y, the sign of proportionality, d over s squared. I said in the first episode, anytime you want to solve any question under variation, you are to ensure you get your variation constant. And what is your variation constant? It is always k. It is your variation constant. And this is our sign of proportionality symbol. Proportionality symbol. Now, viewers at home, let's now proceed. We have been able to jointly join the direct variation and the inverse variation with these keywords, directly and inversely, and we have it on board done already. Now, how are we now going to bring this variation constant? Why we are introducing this variation constant is for us to be able to get rid of this proportionality symbol. Now, it's now going to be y equals to dk over s squared. dk over s squared. If you look at the question, find the law connecting the variables. And for you to find the law connecting these variables, you must ensure you get your value for k. And now we're going to get our value for k. D is 300, x is 24, and y is 1/18. When y is 1/18, D is 30, X is 24. I hope viewers at home, you are following me. And as you are looking at the solution on board, why am I writing when y equals to this, d is this, and x is 24? Is for us to get our constant k. Now proceeding, now we have 1/18 equals to our d is 30k over our x is 24 square. I hope you are following the viewers at home. Now let's cross multiply. I hope you are following me. Let's what? Cross multiply. Now our k is going to be 576 over 18 times 30. I hope you are following me. 24 times 24 is going to give us 576. And we want to make our k the subject of the formula. When you cross multiply, 18 is going to go and mean 30, and 24 square is going to be 576. Now, 18 here 1, 18 in 576 is going to be 32. Now, our k, which is our variation constant, is now going to be 32 over 30. 2 in 32, that is 16. 2 in 30, 15. Our k is 16 over 15. We have been able to get our k, which is 16 over 15. And if you look at the question, we should find the law connecting the variables. We have to find the law connecting the variables. Now, how are we now going to write the laws connecting the variables? And what are the variables? Y, D, and X. We now want to look at the law, how to connect it. So therefore, law connecting the variables is now going to be y equals to our k is 16 over 15 d over s squared. For you to get the law that connects the variable, we are going to get our variable, our variation constant, which is k. And if you look at the solution, this is under joint variation. We are combining our knowledge of direct variation and inverse variation. That is simply what joint variation is all about. Look at the keyword directly, look at the other keyword inversely, and that's what we have solved. Now, taking us further, they also ask us that also find y when d equals to 5 and x equals to 2. Now, let's solve that. They said we should look for y. D equals to 5. X equals to 2. Y equals to 16 over 15 times 5 over 2 times 2. 5 here 1, 5 here 3. That is y equals to 16 over 3 divided by 4, which is going to be y equals to 16 over 3 times 1 over 4. 4 here 1, 4 here 4. So therefore, y equals to 4 over 3. Viewers at home, we have been able to solve this example under joint variation. In the first episode, I listed 4 types of variation, which is direct variation, inverse variation, joint variation, and partial variation. I hope you are able to understand this example under joint variation. Meet me in the next segment. Now we are on the last segment for this topic, variation, and this is partial variation. In the first episode, I listed the 4 types of variation: the direct variation, the inverse variation, joint variation, and partial variation. But in this episode too, we have been able to solve question on joint variation, which I rightly said it is the combination of the two of direct variation and inverse variation. Now looking at the concluding part for this episode, partial variation, I would like you to get a better understanding of what partial variation is all about. Partial variation deals with quantity of variable that depends on another independent variable, where one of the independent variables remains the same always and the other changes according to the quantity of the independent variable used. I want you viewers at home to take notes. Solving problems on partial variation requires forming and finding the solutions of 2 constants. I want you to understand the word 2 constants in a pair of simultaneous equation. Viewers at home, partial variation is the simplest. All what you just need to take note is what I've rightly given on the board, that when you are solving problems on partial variation, it requires forming and finding the solution of 2 constants in a pair of simultaneous equation. In the example, we are going to do justice to this. Looking at an example under partial variation, the cost of maintaining a car is partly constant and partly varies as the distance travelled in a given month. The cost for a particular month is 125 naira when the distance travelled is 300 kilometers, while for a distance of 12,000 kilometers the cost is 350 naira. The now say find the cost for a journey of 16,000 kilometers and the distance travelled if the cost is 230 naira. Solution. From the definition under partial variation I gave, I said when you are solving a problem under partial variation, I said there must be 2 constants introduced to solve it simultaneously. Now if you look at this, we are looking at the cost of maintaining a car, and also we are talking about the distance. These are the 2 variables. Now let's see equals to cost of maintaining the car, and let D equals to distance traveled. I hope viewers at home you are following me. We have looked at the 2 variables. The cost of maintaining a car is partly constant and partly varies as the distance travelled in a given month. Now I said solving partial variation, it involves you introducing 2 constants, and I want you to look at this word partly constant and partly varies. It means that C is going to be A, comma, then D, K, where A and K is a constant. I say it again. A, this A and this D, they are now the constants which I'm going to introduce, and which, if you look at the question, I will now use the simultaneous equation way of getting our answers. And at Mathematics Camp Pro, we already have a video that's been uploaded on simultaneous equation, and which you will enjoy it. Now, taking us further, how are we now going to relate the two? Is that going to be C will be what? A plus DK. This is the relationship. Viewers at home, I hope you are following me, and get yourself off distraction with your writing materials with you. Now we have C equals to A plus DK. Our A and our K, they are what? The constants that I have introduced in getting the relationship connecting the cost of maintaining the car and the distance which the car is going to travel within a month. Now, looking at the question on board, the cost for a particular month is 125 naira when the distance traveled is 300 kilometers. Now, they said 125 is equals to A plus the distance is 300 K. I hope viewers at home, you are seeing it on the board, and I believe you are following the solution. They said the cost for a particular month is 125 naira when the distance traveled is 300 kilometers. While for a distance of 12,000 kilometers, the cost is 350. The cost is 350. It means that 350 equals to A plus 12,000 K. Viewers at home, I hope you can see how these two equations were formed. They said the cost for a particular month is 125 naira when the distance traveled is 300 kilometers. Why? For a distance of 12,000 kilometers, the cost is 350, and that is what I have used in forming this equation. And we must get the two constants, and with together we are going to get the two constants that we have introduced. The first constant is A, while the other constant is K. Now, looking at the equation, now let's subtract equation 2. This is equation 1. This is equation 2. Now, equation 2 minus equation 1. Now, we want to subtract equation 1 from equation 2. That is going to be equation 2, A plus 1200 minus A plus 300 equals to 350 minus 125. What we are doing here, we want to get our two constants. Now we have 12. This is K, and this is also what? K. Now we have A plus 12,000 K minus A minus 300 K. Now 350 minus 125. 350 minus 125. 0 minus 5 is impossible. You move 1 here, that's 10 minus 5. That will give us 5. Remainder 4. 4 minus 2, that is 2. 3 minus 1, that is 2. we have 225. Now A, we cancel A. Now 12,000 minus 3,000. What is it going to give us? 0 minus 0, 0, 0, 0. Then 12 minus 3, that is 9,000. I hope viewers at home, you are getting what I'm doing on the board. Now 350 minus 125 will give us 225. Now 12,000K minus 3,000K is going to give us 9,000K equals to 225. Now let's divide through by 9,000. Let's divide through by 1,000, 9,000. Then our K is going to be 0.025. When you divide 225 by 9,000, we are going to get 0.025. Now if you look at it, it was two constants that was introduced when we started this, A and K. We have been able to get our constant K. Now how are we now going to get our constant A? Now let's substitute K in equation 1. And what is our equation 1? We have A plus 300K equals to 125. This is equation 1. Now it's going to be A plus 300 multiplied by 0.25 equals to 125. What is 300 times 0.025? Now looking at the board, we have A plus 3,000 multiplying 0.025. And when you multiply your 3,000 with 0.025, we are going to get 75. And that is A plus 75 is 125. Then our A is 125 minus 75. Now let's solve it. 125 minus 75. 5 minus 5, that is 0. 2 minus 7, impossible. Then 12 minus 7, that is 5. Our A is 50. We have been able to get the two constants, the constant A and the constant K. I hope viewers at home, you have rightly seen the way we got our K, which is a constant that I introduced. For you to solve partial variation, you must introduce two constants, and I have used constant A and constant K. By the method of simultaneous equation, I have been able to get our K and our A, and our K is 0.025 and our A is 50. Now look at the question further. Find the cost for a journey of 16,000 kilometers and the distance traveled if the cost is 230. Now if you look at the question, it is two questions. They say we should find the cost. We should find the cost for a journey of this, and also we should find the distance traveled if the cost is this. I hope viewers at home, you are following me. In continuation, we have gotten our A. Now let's now look for the cost when our distance is 16,000 kilometers. Now look at the equation. We have C is equals to C is equals to A plus DK. They said we should find the cos. Now this is C. Our A is 50. Then our D is 16,000. What is our K? Our K is 0.025. Then C is 50. Then 16,000 times 0.025 will give us 400. I hope you are seeing how to get the first question. Then our C is now going to be 50 plus 400, that is 900 naira. Now look at the other question. We are asked to look for the distance traveled if the cost is 230 naira. We have been able to look at the cost when the distance traveled is 16,000. Now getting that, our cost is 230 naira. Our D is what we are looking for. Now we are now going to have C equals to A plus DK. 230, our A is 50, D is what we are looking for, and our K is 0.025D. Now this is going to be 230 minus 50 equals to 0.025D. Now 230 minus 50. 0 minus 0, that's 0. 3 minus 5, impossible. You move 1 here. 13 minus 5, that is 8, and we have 1 remaining here. Now we have 180 equals to 0.025D. We divide through with 0.025, also with 0.025. This we cancel this, so therefore our D is when you divide 180 with 0.025, we are going to get 7,200. This is our final answer. Viewers at home, we have been able to look at partial variation, which is the concluding part of this episode to the topic variation. The cost of maintaining a car has been rightly solved on the board. We can see we've gotten our K to be 0.025. We got our A to be 50 with the method of simultaneous equation, and we have been able to answer all the questions. And I know viewers at home, you have rightly enjoyed this video. On the comment section, I'm going to post the YouTube group, our WhatsApp group, for you to further send in your questions. And immediately sending your question, I believe our admin will rightly make justice to them. See you on top in our next videos.
Thanks for watching. Make sure you hit the subscribe button, like and share. Have a blessed week. Bye.